So there are 4 practice problems posted on the website under practice. They're files at the bottom of Unit 10. So the expectation would be that you've already worked them when you come to watch this screencast. So if you haven't, you should pause this or stop this, and you should go look at those questions and try to solve them on your own first, and then pretend like this is me in class talking you through problems. I'm going to walk through each one step by step. Here's the first one. So first of all, let's start off looking at oxidation numbers. And what you should do first if you're trying to say oxidation numbers is to write down the ones that you know. And there are some rules that you were supposed to learn from Unit 10 that we also learned a few units ago. So that's what we want to apply here first. So the ones that I've written down already are the ones that you should know. And then because of those, you should be able to solve for the other one. So like this one you know is going to be plus 2 because they have to add up to be 0. This one, since there's 2 of those oxygens, this nitrogen is going to be plus 4. And then over here, this one is going to be plus 3. So when you look at the oxidation numbers, what you should notice is that nitrogen is going to change into 2 different numbers on the product side. So he's going from plus 3 to plus 2. He's also going from plus 3 to plus 4. Just simply by knowing that, you should now be able to label oxidation and reduction, as well as the oxidizing agent and the reducing agent. So hopefully you group it up like this, where you have the reduction half reaction and the oxidation half reaction. Once you've done this, you absolutely already know which one's the reducing agent and the oxidizing agent. In this case, it really doesn't matter because it's the same compound, but since this is the reduction half reaction, this would be the oxidizing agent, and since this is the oxidation half reaction, this would be the reducing agent. Now let's go through and balance out our equation. So remember, the first thing you have to do is balance out the oxygens by adding waters. So I had 2 oxygens over here and only 1 on this side. So I added 1 water to balance that out. Now my N's are balanced, my O's are balanced, my H's are not, so I'm going to add H plus on this side. Once I do that, my atoms are balanced. 2 H's, 2 H's, 1 N, 1 N, 2 O's, 2 O's. So then now I need a balanced charge, so I need to add 1 electron on this side so that I have 0 charge on this side and 0 charge on this side. My reduction half reaction is balanced. Now I'm going to do the same thing on the other side. In this case, my oxygens are already balanced, so all I need to do is add an H plus to balance out the hydrogens and then an electron to balance out the charge. So remember, before you put these 2 equations together, you have to look at the number of electrons. In this case, both of them are 1, so all we're going to do is add these 2 equations together. So the electrons cancel out because they're the same on both sides. And then when I write it like this, though, I should notice that I'm repeating myself again. So I have these on this side and these on this side. So I need to cancel those out as well. So my final answer is actually going to be and when you double check, 2 H's, 2 H's, 2 N's, 2 N's, 4 O's, 4 O's, no charge, no charge. This is my balanced overall redox equation. So here's our next one. So let's go in and fill in the oxidation numbers that we know again. So the ones in red are the ones that you should know based on your rules. Remember, oxygen and arsenic are both free elements. Free elements always have an oxidation number of 0. So then you need to solve for arsenic on the product side. You should have gotten that arsenic was plus 3 because remember the sum of oxidation numbers of a compound is 0. So then now you should be able to identify what's being oxidized and what's being reduced. So these are the 2 equations that you have or that you should have written, and what you should see is arsenic's going from 0 to 3. So that should be your oxidation half reaction. So this better be a reduction half reaction. So let's check. Here's oxygen, it's a 0, and it's going all the way over here to a -2, so 0 to -2. That is a reduction half reaction. So again, now that you know which one's the oxidation reaction and the reduction reaction, you should be able to identify which one's the reducing agent and which one's the oxidizing agent. So based on which one's in the half reaction, you should be able to identify that oxygen is your oxidizing agent and arsenic is your reducing agent. Remember, you're always choosing those from the reactant side of the equation. So now let's start with the oxidation half reaction and let's go ahead and balance it. Remember, you start off balancing your oxygens by adding waters to the other side. So I needed 2 oxygens, so I added 2 waters, and then now I need to balance out my hydrogens. I have 4 hydrogens on the reactant side, and I have 1 on the product side, so I need to add 3 H pluses. Once I do that, my atoms should be balanced, and so then the next thing I need to do is look at charge. I have 0 charge on the reactant side. I have a +3 charge on the product side, so I need to add 3 electrons. Once I do that, if you look at it, it is balanced by atoms and by charge, and my electrons are on the product side, which means they're being lost, which is definitely valid when it's an oxidation half reaction. Now let's try the other one. Remember, you add waters to balance out your oxygens. And then once you balance out your oxygens, you add hydrogens on the other side. And once you balance out your atoms, then you balance out your charge. I have a +4 charge on the reactant side. I have a 0 charge on the product side. I need to add 4 electrons. And once I do that, I have 4 hydrogens on the reactant side, 4 on the other, 2 oxygens, 0 charge, 0 charge. Now, if this were me, I would rewrite this and I would combine those 2 waters together. Okay, so once you have gotten your 2 half reactions, then you look at the number of electrons. This one has 3, this one has 4. Remember, that has to be the same number. So what I'm going to do is I'm going to take this equation and I'm going to multiply it by 3. I'm going to take this equation and I'm going to multiply it by 4. That way I'll have 12 electrons on both sides, and then that would cancel out. So for some of you, you're able to do this math and multiply in your head and combine. I always think that it's safer to write out what these equations would look like. So notice that these are the new equations. You need to make sure that you actually, though, do write out this equation like this, and this equation like this. Don't multiply the 4 through your original half reaction. Your half reaction is what I have marked in orange. The only reason why we're multiplying it is in order to come up with the overall redox equation. So when you add them together, this is what you get, and what you should notice is you have something that repeats on both sides, so you want to get rid of those. So when you rewrite this final equation, you're not going to have that in your final balanced redox equation. What you also need to see is that you have 8 waters and 6 waters on this side. So you want to combine those as well. So that's actually going to make this a 2 over here and 0 over here. Okay, so now let's rewrite our final answer. Okay, so this is a good way to demonstrate how important it is to make sure that you double check everything. You really shouldn't be missing a redox equation. So when I was going through and trying to figure this out, when I was trying to balance it out, my O's aren't balanced. So I have 2 O's here and 6 O's here, so 8 oxygens on this side, but I have 16 on the other. So I went back and I double checked my reactions, and I caught that I don't know how to copy numbers correctly. So I'm going to be able to fix my equation, and the only reason why I caught that was because I was double checking my work. So make sure on the quiz that you double check your stuff. Remember, they need to balance by atom and by charge. And this is your overall redox equation. Let's try number 3. So again, let's start off practicing doing our oxidation numbers. The ones I wrote in red are the ones that you should know based on your rules. Oxygen is always -2 unless it's a peroxide. Free elements are always 0. And so solving for the other ones, you just have to remember this one has to equal -1 when you add those together. This one has to equal -1. This one doesn't have a number, so it has to equal 0. That's actually a compound, not an ion. Okay, so now let's separate into oxidation and reduction half reactions. So simply by looking at the oxidation number of a specific element, you should be able to identify reduction and oxidation. So on this one, nitrogen's going from +5 to +4. Well, that's a reduction. The oxidation number went down. Iodine's going from 0 to +5, so that's an oxidation number. That's an oxidation reaction because the oxidation number goes up. So as a result, you should be able to recognize that this, then, since nitrogen is here, this is the oxidizing agent, and then this is my reducing agent. Okay, so let's write out our half reactions. So this is how you should have separated them out. once you copy from the balanced equation, remember you add waters to balance out your oxygens. So in this case, I need 2 waters to balance out my oxygen. So I have 3 oxygens over here, 3 oxygens over here. Then I'm going to add hydrogens on the other side to balance those out. And then once I do that, then my atoms are all balanced. So then now I need to look at charge. I have +3 charge on the reactant side, 0 charge on the product side. So I need to add 3 electrons. My electrons are on the reactant side, which is where they're supposed to be for a reduction half reaction. I am balanced by charge and by atoms, so I am done with my reduction half reaction. Now moving on to the oxidation half reaction, and I start over balancing my oxygens by adding waters. But, oops, forgot. For this one, you need to balance the atoms that you have first. So look, there's 2 of those here. So you need to start off by doing that first. Now balance out your waters. So there are 6 oxygens on the product side, so I need to add 6 waters. Now I need to add my H pluses. And then I need to balance charge. 0 charge on the reactant side, plus 10 charge on the product side. So I added 10 electrons. And so this is what you get. And then remember, these electrons have to be the same, so you're going to have to multiply your equations. So when I do that, I get these equations, and then now I'm just going to combine them. Remember, if I see something on both sides, so something like this and this, well, that means that they're going to cancel out, so I'm going to have 2 waters on this side. If I were looking at H's, these and these, there's 40 on the reactant side, there's 36 on this side, so the H's are going to be on this side. And then here's my arrow between the 2. So you're trying to cancel out things that show up on both sides. Let's finish it out. So when you add all of those equations together, you have 6 I's, 6 I's, 4 H's, 4 H's, 10 N's, 10 N's, 30 O's. You have 18 O's here, plus 10 more, that's 28, plus 2 more, that's 30. So atoms are balanced. Then I look at charge, plus 4 here, minus 10 here, so minus 6 total, minus 6 on this side. This is balanced, and this is your overall redox equation. Again, remember, you'll be able to double check your work, and I don't know if you caught it earlier. I had a subscript here, and then I forgot to put that charge here. And the reason why I caught it and I went back and fixed it is when I wrote my final equation, it wasn't balancing right. So I went back and was just being more careful. So just make sure you're conscientious about your subscripts and your superscripts, and then make sure you take time to double check. All right, let's do the last one. So again, start off, let's practice doing oxidation numbers. So the ones I have up in red are ones that you should know based on your rules. The one in blue you had to solve for. So let's see if we can figure out who is being oxidized and who is being reduced. So based on our oxidation numbers that we have written there, I've identified where the reduction is going on and where the oxidation is going on. And because of that, I can label my oxidizing agent and my reducing agent. Okay, let's write our 2 half reactions. So this is how you should have separated them out. Let's start off with our reduction reaction first, so you need to balance oxygens by adding waters. I have 3 oxygens, so I added 3 waters. Now let's balance out our hydrogens, and then after that, let's balance out our charge. So when you finish that, you have -1 on the reactant side, -1 on the product side, 6 H's, 6 H's, 1 Br, 1 Br, 3 O's, 3 O's. Let's move on to the oxidation half reaction. In this case, the atoms are already balanced, so all we have to do is balance out charge. That one was pretty easy. So then now remember that the electrons that are gained have to be equal to the electrons that are being lost. So we're going to have to multiply the oxidation reaction by 6. Remember to make sure that you leave your oxidation half reaction as you originally wrote it, but then just do the brackets with the 6 on the outside. And then if you want to, you can rewrite it underneath once you changed all the coefficients. And then once you do that, since the electrons are equal, you are ready to bring your equations together. So when you do this, this is what you get when you add them together. Remember, the order that you write things in doesn't matter. They just need to be on the correct side of the arrow. 6 H's on this side, 6 H's over there, 6 Fe's, 6 Fe's, 1 Br, 3 O's. Total charge is positive 17. Total charge is positive 17. Here's your final overall redox. Hope that helped. See you Monday.